All right, so we're going to talk about polynomials. We've talked a little bit about polynomials, but really all we've said is that polynomials have a domain that's defined everywhere. We're going to talk about polynomials all unit long. This is a non-calculator day. Okay, characteristics of polynomials. All exponents are whole numbers, so that means you have x raised to some number, and that's going to be a whole number. So whole numbers are 0, 1, 2, 3, etc. Okay? Not negative, not fractions. No variable is contained in a denominator, so no 1 over x, and no variable is under a radical. Notice that it's saying a variable is not under a radical. You can have a radical, just not with a variable underneath. All right. The degree of a polynomial is the exponent of highest power of the variable. That's the degree of the polynomial. And the coefficient of this highest power of the variable is called the leading coefficient. Okay, so let's do some examples. Here's an equation. We're going to tell me if it's a polynomial. If so, what's the highest degree, the leading coefficient, and the constant term. So in this first example, all three of those characteristics are satisfied. So this is this is a yes, sorry. And 6x to the 7, I'm going to square that one because that contains the highest exponent of 7. So 7 is the degree, the highest exponent is the degree. And then 6, the number that is the coefficient of that high degree is called the coefficient, leading coefficient. Okay? It's like this guy is the most important part of the polynomial. We're also going to use the constant term a lot, so that is the number that's all by itself, so that's 10. Positive 10, just write 10. All right, the next one. So if you look at the characteristics, you've got x to the 2/3. That makes this not a polynomial. Okay, don't fill in the rest. Next, x cubed. So this is a polynomial. It's got a high degree of 3, a leading coefficient of 1, and no constant term, so 0. All right, the next one. This guy right here, big problem, not a polynomial, cannot be in the denominator. This next one, you might be thinking no right now, but it's actually a yes. And the reason is it actually has a lot to do with an old property of Algebra 2. Notice that I included the exponent of 0. So if I ask you, what is x to the 0? Or anything raised to the 0 power is 1. So what that means for me, if I come back down here to my problem, is I could rewrite this as 12 times x to the 0. Because if x to the 0 is 1, 12 times 1 is still 12. So it's just kind of a different way to write it. So you do have an x, and it's got a polynomial or a degree of 0. That's the only degree we see. But still, none of those characteristics are, violated. I mean, it is a whole number. It's just kind of a weird whole number. Okay, it's not in the denominator. A variable is not in the denominator, and the variable is not under a radical. So this is a polynomial. The highest degree, well, the only degree we see is a 0, and the coefficient in front of that is a 12. Now, it's kind of weird, but that leading coefficient is also the constant term because 12 times x to the 0 is a constant term of 12. All right, and then in the last one, so if you want to pause it and see if you can do the last one on your own, before you do that, you might want to really make sure, I'm just going to say, that this guy, you should usually put them in descending order, so you would probably start with this guy. If we were doing this problem, I would tell you to rewrite it as this. Okay, so you can go ahead and see if you can fill in the rest. You always want to write the problems in descending exponent order. All right, so this is the important guy. All those characteristics are satisfied. Degree of 8. Leading coefficient of -1, and a constant term of -4. All right. Polynomials of degree less than 5 are often referred to by special names. So I'm going to write the example first, and then I'll talk about the name. So first degree polynomial. So for example, y equals x raised to the first degree, x to the 1. Well, that's kind of silly. We never say x to the 1. That's the same thing as just x. Y equals x, those are our linear functions. Okay? Y equals second degree, x squared. Those are our quadratics. X cubed, the third degree, y equals x cubed, those are cubic. And then lastly, y equals x to the fourth, those are quartic. I've never memorized this. I have to look it up at the start of this unit if this comes up on a quiz or a test, I will be sure to remind y'all before we start. All right, let's go on to page 2. So page 2, we're getting into the operations. So operations include adding and subtracting, multiplying, and dividing. All right, so the first one, if we subtract, we know that when this subtraction sign is in front of the parentheses, we have to distribute. So go ahead and distribute that. So that's negative 2x cubed plus x minus 4. Okay, and I'm just going to rewrite this. There's nothing that indicates it needs to change at all, so I'm just going to rewrite that. So negative 2x cubed plus x squared minus 4x plus 1. And then from here, it's really just about combining like terms. Negative 2x cubed minus 2x cubed makes negative 2 and negative 2 makes negative 4. So negative 4x cubed. This is my only square term, so plus x squared. My x's, I've got minus 4x, and plus x makes minus 3x. And my regular numbers, I've got positive 1 and negative 4, so minus 3. Okay, multiplying. So when we multiply, it's basically just distribution. So I'm going to distribute this 3x squared to 5x cubed, negative x squared, minus 4x plus 2. As a super quick reminder, if I ask you what x squared times x to the third is, so what that really is like, or at least when you're learning these properties, is it's x times x, that's x squared, and then I have times x times x times x. So 5 x's are being multiplied, so that's x raised to the fifth. Okay, so the shortcut that you ended up learning in algebra is that if you just add 2 plus 3, that's going to get you that. So keep that in mind. This gets a lot easier. You don't have to really think about those rules. 3x squared times 5x cubed, so 3 times 5 is 15, and then x to the fifth. 3x squared times negative x squared is negative 3x to the fourth. 3x squared times negative 4x makes minus 12x cubed. And 3x squared times 2 is 6x squared. Okay? All right, and B. Same thing, just a little more complicated. We're going to do 2x times this guy, and this guy. Then we'll do minus 3 times this guy, and this guy. So 2x times x squared is 2x cubed. Then I'm doing 2x times 3x is 6x squared. Then I'm doing 2x times negative 5 is minus 10x. Now I'm doing negative 3 times x squared is minus 3x squared. And then I'm doing negative 3 times 3x is minus 9x. And lastly, I'm doing negative 3 times negative 5 makes positive 15. Okay, if we do some combining of like terms, I've got 2x cubed, that's my only x cubed term, so 2x cubed. I've got 6x squared with minus 3x squared, so positive 3x squared. I've got negative 10 minus 9 minus 19. And 15 is the only number, plus 15. All right, let's go on to division. I went really fast because hopefully all of that stuff is just a review. What's going to be new for us is the dividing part. So, I guess before we start dividing, let me talk about something. So if I ask you, what is 112 divided by 5? You would say, well, 112 divided by 5. Does 5 go into 1? No, it doesn't. Does 5 go into 11? Yes, 2 times 5 is 10. Subtract, 11 minus 10 is 1. Bring down the 2. So does something times 5 go into 12? So yes, it's 2 again. 2 times 5 is 10. Subtract, 12 minus 10 is 2. Now at this point, you had a couple of different options. Most people, what they remember is you put the decimal here, so you put a decimal here, you bring down the 0, and that's fine. 5 goes into 20 4 times, and it ends up being even, so there's nothing more to do. That's a good method for decimal answers. Now, we don't want decimal answers. So instead, I'm going to erase this. I'm going to erase this and this. Okay, so we got here, and we got that the remainder is 2. Well, if you work with fractions, which is what we're going to be doing, 2 is the remainder because it didn't go, 5 doesn't go into 2 any more times. So 2 out of 5 is what's left. So what you end up having with fractions is 22, and so adding 2/5 to that, because it's not just 22, it's 22 and 2 out of 5 is left over. Well, if you notice 2/5 in decimal form, that is 0.4. So they are the same thing, it's just that this is the decimal answer and this is the fractional answer. We're going to be doing this, okay? All right, so if you really understand all of this stuff, your long division of polynomials is extremely similar, it's just a lot more complicated. So let's go ahead and come back over here. So we take this outside, or we take this divisor, and we write it here. I am going to keep it in parentheses. I think it's a little bit easier for you to remember to distribute if I write it in parentheses, okay? Then the dividend, the thing that is being divided, goes here. If you look really closely, what do you notice about this compared to this? 3x to the 4 minus 8x squared minus 11x plus 1, 3x to the 4 plus 0x cubed minus 8x squared minus 11x plus 1. So, hopefully by me accenting or accentuating, you can see this guy, 0x cubed, was not here. It is something that we inserted in because you need to have every degree represented. So what I mean by that is we started with a degree of 4. You need to see a degree of 3, a degree of 2, a degree of 1, and a no degree, or a plain number. So they inserted it in. If you notice, look at these two things again. This is 0 times x cubed, which is just 0. So it's not like they're changing the equation, they're just changing the appearance, because this is like a big fat 0. Nothing has changed about it. They're just adding a weird form of 0 so that the column, which I'm going to talk about, but so that this x cubed term is represented, okay? So before you start, when I read this problem, I would have made myself a little note and wrote 0x cubed needs to get introduced so that I remember to do that, okay? All right, so now let's go ahead and start. Let me say, neat handwriting might be a good thing, so if you try really hard to keep your handwriting neat and just organized, nice columns, all those things, okay? All right, So I start by saying, what am I going to put here so that when I multiply it times x, I get 3x to the fourth? So the first thing, well, I need a 3 because I have a 3 here. And then I need more x's. This is going to be x cubed because x cubed times this x is going to get me to the x to the fourth. So I chose this because now when I distribute it in, I get exactly 3x to the fourth. But this is why I put these parentheses here, is because I can't just multiply it there. I also will have to multiply the 2, or the negative 2, I should say. So 3x cubed times negative 2 is negative 6x cubed. Okay, the step I say in my mind is parenthesize, subtract. So 3x to the fourth minus 3x to the fourth. So 3x to the fourth minus 3x to the fourth, well, that goes away. That's supposed to happen. I chose that so that that exact thing happens. Okay, now I've got 0x cubed minus negative 6x cubed. Again, I put this in parentheses so that that minus sign distributes. You cannot forget to do that distribution. So some people like to go ahead and write, like they cross it off here, and they say minus the negative really makes plus. If you want to do that each time, you can. Or if you just want to, I kind of just point to it and do that. Whatever method you think you're going to remember to do. I'll kind of switch back and forth. So 0x cubed plus 6x cubed makes 6x cubed. Okay? You need to bring down minus 8x squared. So you're not going to be done until there's nothing left to bring down. Repeat. So now I say, what times x is 6x cubed? So I have a positive 6, so plus 6x squared. So 6x squared times x is 6x cubed. Again, I chose that so that those two things would be exactly the same. 6x squared times negative 2 is negative 12x squared. Parenthesize, subtract. So 6x cubed minus 6x cubed goes away. That's supposed to happen. Negative 8x squared minus negative 12x squared. So if you want to write that little intermediate step, this minus negative really makes plus 12x squared. Let me write it again, plus 12x squared. So now I'm doing negative 8 plus 12 is 4. So 4x squared. Bring down the minus 11x. Okay, still going. So what here times x is 4x squared. So let me go back. I'll use red. I need 4 and I still need an x. So 4x times x is 4x squared. 4x times negative 2 is minus 8x. Parenthesize, subtract. So 4x squared minus 4x squared goes away. That's supposed to happen. Negative 11 minus negative 8. Negative 11x plus 8x. Negative 11 plus 8 is negative 3. So now I've got negative 3x. Still not done. Last one though. It's the last piece to bring down, plus 1. Okay, so you got to say, what times x is negative 3x? So you do need to represent that with a minus 3. So that makes negative 3 times x is minus 3x. Again, those are right on top of each other. They should match. And then plus 6. Parenthesize, subtract. So this goes away. 1 minus 6 is negative 5. That's your remainder. Okay, if you wrote down that 112 divided by 5 example, or if you can recall that, think about what we did with the remainder. So our final answer is this guy plus the remainder over the divisor. Remember, for the 112 divided by 5, we got the answers 22 and 2/5. So kind of just keep that in the back of your mind. So this is going to be 3x cubed plus 6x squared plus 4x minus 3, and then minus, the reason I'm doing minus is because it's -5 as a remainder. So I put the minus or the negative as a minus, and then 5 over x minus 2. Okay? All right, let's go on to the next example. All right, let's go on to example B. So I know what's coming up in the notes, and we're about to also look at synthetic division, and there's a limitation to synthetic division. So what I want you to write down, because I can't really go back and forth in pages when I'm recording, so I want you to circle this and write in your notes. Don't write it as big as I'm going to write it, but say this divisor of x squared, so I'm talking about this x squared here. I know it's 2x squared, but it's really only the power of 2 here that's causing this that you're writing down. I know this probably doesn't make sense right now, but I want you to write it down so you have it in your notes. And then I'll explain it when I get to the correct location on page 3. But this divisor of x squared means you cannot do synthetic division. Okay, so I'm going to talk about when you can and when you cannot do synthetic division later, but it's basically, I'll just go ahead and say it's basically when you have a degree of 2 or more. So this example, you cannot do synthetic division. It has to be done using long division. Must be done with long division, which is the one we just did. Okay, so let's go back really quickly. This example that we just finished, when we learn synthetic division, I'm going to show you that this example can be done using synthetic division because the divisor, x minus 2, that's an x raised to the 1 power. That's when you can use synthetic division, which is a shortcut for us. But you have to learn long division because there's certain cases that synthetic does not work, okay? So example B, this is an example that you have to, the reason why we have to know long division. So make sure this is on your notes, but I'm going to go ahead and erase it so I have enough space to work. But you do need to write that down. All right, so let's do long division again. Remember that first step, we need to make sure all of those little degrees are represented. So I have a degree of 3, 2, 1, and none. That's good. On bottom, I have a degree of 2, and then I go to none. I don't have 1. So let's cross this off and write 2x squared. We need 0x. You need that single x term plus 1. Okay, so again, it's about changing the appearance of the problem. All right, so 2x squared plus 0x plus 1 and 6x cubed minus 4x squared plus 3x minus 2. Okay, let's start. So I'm going to go a little bit faster. You might want to pause it if you want to try and do this. What times 2x squared? Oh, let's put parentheses so that I remember to do all of it. All right, so what times 2x squared is 6x cubed. So I need a 3 and I need an x. So That makes 6x cubed plus 0x squared plus 3x. Parenthesize, subtract. So this goes away. That's supposed to happen. Negative 4 minus 0 is negative 4. Anything minus 0, right? And then 3 minus 3. 3x minus 3x is 0x. Bring down minus 2. So this should be our last step because there's nothing left to bring down after this. One more. So we've got what? What times 2x squared is minus 4x squared. So I need the minus and 2 times 2, so 2 here. So 2 times, or negative 2 times 2x squared is negative 4x squared. Negative 2 times 0x is minus or plus 0, doesn't matter, because it doesn't matter if you're adding 0 or subtracting 0. And then negative 2 times 1 is negative 2. Parenthesize, subtract. So negative 4 minus negative 4 goes away. 0 minus 0 goes away. Negative 2 minus negative 2 makes really negative 2 plus 2, which is also 0. I've got 0 all the way down. So I've got a remainder of 0. So this is my answer. You don't need to write plus 0 over. That doesn't matter. 3x minus 2 is our answer. Okay, so what does that mean? Well, let's go back to numbers, because I know it's a lot easier to understand. If I ask you 20 divided by 5, I mean, we don't even have to do that work. We know that that's 4. There's no remainder here. Remainder is 0. And that's because 4 and 5 are exact or perfect factors of 20. So 3x minus 2 is a perfect factor of 6x cubed minus 4x squared plus 3x minus 2. Okay? So that's going to be something that we talk actually quite a bit about later on in this unit. So just keep in mind, remainders of 0, they happen. They're actually a good thing. It means that it's a factor. All right, let's go on. Okay. Synthetic division is a method when the divisor is a first-degree binomial. So this is what I was kind of trying to talk about when I was making a big deal about writing down when you can and can't use long division. So both of these are good examples of when you can use long division because your divisor is x raised to the 1 power. X raised to the 1 power. If you have anything else, x raised to the 2 power, x raised to the 3 power, anything else, you cannot do synthetic division. Now, synthetic division is a shortcut. Personally, I don't like synthetic division. There's no rhyme or reason why it works. It's just a whole bunch of shortcuts that always work, okay? It's something you have to memorize the steps, but it is a lot easier of math. It's just, there's no logic to it. It's just memorization, okay? So if you're one of those people that just want to memorize something and be done, this is for you. All right. Here's the setup. You have to memorize the setup. You put a little box. You put some numbers here. Okay? So what goes right here? Well, it's from this thing. X minus 2. And if you set that equal to 0, you get x equals positive 2. So that's what goes right there. Or a lot of people just say if this is negative, use positive. That's fine too, but I mean, this is the y. So this is from this. Now, these guys, 3, 0, negative 8, negative 11, and 1. These are, let me do this in blue. These are your coefficients. If you are noticing this problem seems familiar, it's because this is actually the first problem that we did. So we're just going to show that the answers are the same. So if you want to flip back to the front page or to page 2, you can see that it's the exact same question, just we're solving in a different way. So again, I'm going to talk about how this is degree of 4, degree of 2, 1, and none. They're missing the degree of 3, so that's why they inserted the 0 right here. So before I started this problem, I would probably do a big reminder, 0x cubed. So that's where they're getting this 0 from. Okay, so let's do some more setup. You need a plus sign, you need an arrow, and a line. Okay, so this arrow is telling you bring down the 3. So all of this is part of the setup. I haven't done anything yet. Now, my rule that I remember is that if I make a diagonal move, let me do a different color actually. If I make a diagonal move, I multiply. So this is a diagonal move. Or if I make a vertical movement, I add. Okay? All right. So I'm going to try to do this color coordinated. So 2 has to multiply 3. That's a diagonal movement because they're not lined up exactly on top of each other. So 2 times 3 is 6. That goes here. Okay? Now I do 0 add 6. 0 plus 6 is 6. Okay? Do it again. I know this doesn't make any sense why this works. It just works. 2 times 6 is 12. Now, negative 8 plus 12 is 4. Do it again. 2 times 4 is 8. Negative 11 plus 8 is 3. Lastly, 2 times 3 is 6. I'm sorry, I messed up somewhere. Hopefully you caught it. Negative 11 plus 8 right here is actually negative 3. And then 2 times negative 3 is negative 6. 1 minus 6, or 1 plus negative 6 is negative 5. Okay? Then your answer, okay? You start with the right with an R. Right is for R. Actually, it's for remainder, but that's how you can remember it, is on the right-hand side, you put an R, then you increase your X values. So if you have X to the nothing power, so maybe if you want to write X to the nothing, that's fine, but X to the nothing is 1. So this is like your number location, then your X to the first power, X to the second power, X to the third power. So these are the answers. So the answer is 3x cubed. This is a positive 6, so plus 6x squared. Positive 4 plus 4x minus 3. Remainder. So this is where we put, the symbol is negative for 5, minus 5 over, and then go back to the top, x minus 2 was the divisor. So if you flip back to page 2, which I can't do, but if you flip back to page 2, example 3a, this is the exact same answer we got. You can see it's a lot shorter of a process, but it's a whole bunch of steps you just have to brute force memorize, okay? All right, so let's do, what I'd like for you to do, because you have to remember how to set it up, is cross this off so we can practice how to set it up. Don't look at it, just cross off all those numbers. So what I do is I draw my box. I draw this big line. That kind of reminds me of an American flag. I mean, here's where the stars go, the stripes. So I don't really know. You got to figure out something to make you memorize that. Plus and an arrow. Okay. X plus 3 tells me x plus 3 equals 0, so negative 3 goes here. Then what goes here are all of these coefficients. Before you just write them all down, make sure all the degrees are represented. So I got a degree of 5, 4, 3, 2, 1, 0. So this one, they are all there. So I can go ahead and just write those exponents, or write those coefficients down. So 1, 5, 6, -1, 4, and 29. I'm going to extend this line just a little bit. Okay. Now the reason why we wrote this arrow right here is because that first number you just bring on down. And now you start, this is a diagonal, this is a vertical. This is a diagonal, this is a vertical. So -3 times 1 is -3. 5 add -3 is -2. -3 times -2 is oh my gosh, I'm really sorry. I'm not gonna, there's no excuse. 5 plus -3 is +2, not -2. Okay, -3 times +2 is -6. 6 plus -6 is 0. -3 times 0 is 0. -1. 3. 7. -21. 8. This is my remainder. Then I can have a number, x, x squared, x cubed, x to the 4th. So you just keep going until you have no more to go. So our answer is 1x to the 4th plus 2x cubed. I would not take off if you wrote plus 0x squared. I typically don't write it. Minus x plus 7. Remainder is +8, so plus 8 over, and then x plus 3 was the divisor. So you're coming back up to here. X plus 3 was the divisor. Okay? All right, and that's it.